Greetings, welcome to APchemistrycourse. In today's lesson, I'm going to talk about the story of the R in ideal gas law. Alright, we talk about the ideal gas law, but what's up with the story of the R and that bizarre number 0.0821 and can differ, by the way, and we can give examples right now. Alright, let's talk about it. So the idea of the R. The idea that we saw as, for example, the number 0.0821 Latin over Kelvin times mole. How did we get that number? In order to answer this question, we'll do a simple example. So, we are given the ideal gas law formula, and in order to get the number, we need to solve for R. So, in order to do so, we need to leave R in one side of the equation. So, that means that the t and the n must go. That means we're going to be left with the formula of R equals PV and T. Alright. So, as you can see, we need to start solving according to that formula. So, to do so, we need to do such a thing. That we need to get the numbers that are given by a law, which is called the Avogadro's law. Well, do you remember Avogadro's law? It's a law that states that at STP, temperature will be 0 Celsius and the pressure will be 1 atm, and gases at any type or any type of gas will occupy per 1 mole 22.4 liters. Let's state that again, that at STP the temperature will be 0 Celsius, pressure 1 atm, and the 1 mole of any gas will take up 22.4 liters. Alright, so per 1 mole we have 22.4 liters. Great. So, according to this information, what data do we get? You're right, temperature, pressure, number of moles, and volume. Interesting. How many units are we missing here? 4. Now, is that a coincidence? I think not. So, using this data, what can we do is that we write R equals the pressure, we put it up there, 1 atm, and then I'm going to put the volume, which is going to be 22.4 liters. Alright, so then we're going to put the number of moles, which is going to be 1 atm. The number of moles, 1 mole, multiplied by what? The temperature, which is going to be 0? Of course not. We're going to have the unit in Kelvin, as we remember. And how to do? How's it done? We write it as 273.15 plus the number of Celsius equals Kelvin. Now 0 is placed right over here because we have 0 Celsius. That means we're going to have 273.15 Kelvin as a unit. So, let's do the math. Nothing cancels nothing out. If I put a dash under the units, liter is going to cancel moles nor Kelvin. Kelvin cannot cancel atm nor L. So, there are no units that are changed. Let's do the math. So we're going to have up 1 times, let me just put it, 22.4 over, under it there's 1 multiplied 273.15. Alright, let's put equals, and the number that is given is simply this. R equals 0.0821. Now I don't know what's with my calculator, but it just gave me this number because I tried other calculators just to be sure that the number is correct, and I got different numbers. For example, we got a 0 right over here, and I don't remember, I think a 5 or anything, or something larger than that, because after that, if we just round it for 3 significant figures, we can notice that we have here 1, 2, 3 significant figures, and the largest is 1, 2, 3, 4, 5, 5. So we can take just the 3. So those are not significant figures. If we take 1, 2, 3, we take the number next to it. Let's say it ranges from 5 to 9. All right. Then what we are going to get is that it's 821. So depends on your calculator. Do not worry if you got the number, for example, 8,200, for example, and 6 right over here. You can just round it up and we're going to get the number, for example, 821. If we have 6, it will work, and whatever. So at the end we're going to end up with 821. Interesting, isn't it? But what about the units? The units are going to remain constant. ATM will always be up. Liters will be up. Moles will be down. Kelvin will be down. So nothing is gone. It's just as it is. What about the other units? It's really simple, to be honest, because you can just use the formula that I mentioned in a video called Conversion of Gas Units. As you remember, 1 ATM equals to 760 torr, or millimeters of mercury, or that equals to 101.3 kilopascals. So whatever you do here is that what I'm going to change here is always to change the data given is the number of pressure. So if I change now to 760 torr, if I put that 760, what are we going to get? The R data for torr, let me write torr, will equal 6. I don't think that will be shown in the camera, so let me go higher here. So for the torr, it's going to be 62.3 approximately. That's going to be for the R unit. Let's go for kilopascals. Kilopascals is going to be equal. It will equal to, if we switch that unit to 101, 1.3. Of course, we're switching only the pressure because we're converting, as we're keeping Avogadro's law, we're just putting this conversion for the unit right over here, because 1 ATM equals 760 torr equals 101.3 kilopascals, so we can get the different numbers of what they are. So for kilopascals, it's going to be 8.30 or 8.31 if we have, wait just a second, 1, 2, 3, 4, 1, 2, 3, so I have 1, 2, and here's the 0, 7, so 1, 2, 3, the number next to that 7, so it's going to be 8.31. So that's also the digits of R for kilopascals. So those are the different R what's called numbers. We have one for ATM, one for torr, and one for kilopascals. So this is the simple way that we use to calculate R, and what is the story behind it. So this is all about our lesson for today, and I hope it is useful. Don't forget to check out other videos of the playlist of gases, not to lose your track. Alright, so this is all about our lesson for today, and I hope it is useful. Have a good day.